Hey guys, today you are going to learn something called prime factorization. So we reviewed what factors and multiples are, and then we did prime numbers and composite numbers, and you need kind of both of those things for today's lesson. I think prime factorization is something that is new to you, and it's actually one of my favorite things because it's kind of like a puzzle that you have to figure out about numbers. So to get your brain thinking in the right direction so we can learn prime factorization, I want you to complete this warm-up. So I would like you to list the first 5 prime numbers. So like starting at 0, what are the first 5 prime numbers? And then I want you to list the first 5 composite numbers. Okay, so pause the video and try to come up with those. Okay, so hopefully you paused it. So the first 5 prime numbers. So hopefully you figured out yesterday or saw in the formative that 1 is neither prime nor composite. It does not fit in either category. That was the trick in your slideshow yesterday. So 0 and 1 are not in either category because it has to be a number greater than 1. So you want to skip over 1, and then the first number is 2. Well, 2 is actually a prime number, so it should have been in that list. Then you have 3. 3 is prime because its only factors are 1 and 3. Next number is 4. 4 is composite. Then 5 would be prime. 6 is composite. 7 is prime. 8 composite. 9 composite, 10 composite, and then 11 would be prime. And there's our first 5 prime numbers and first 5 composite numbers. So this list of prime numbers, and even at 13 on there, that's your next one, I would memorize those prime numbers. You're going to need that when it comes to this whole entire unit. So 2, 3, 5, 7, 11, 13. The most important prime numbers. You're going to use those a lot. Okay, so I would write those down. Make sure you have a list somewhere that you can always access. Maybe write them on the top of the packet that you picked up for my class or I gave you for my class. Okay, so prime factorization. So at this point, I want you to pause and write down the definition of prime factorization. And then as I go through what it is for 4, 6, 8, and 10, I want you to be taking notes. So you need your notebook out, taking notes so you know what you're doing. So pause and write down the definition. Okay, so hopefully you have the definition down and you are ready to go. So prime factorization is, or of a composite number, is the number written as a product of its prime factors. So product tells us we're going to be multiplying prime factors. So basically every composite number in the entire world can be broken down and you can multiply prime numbers to get that composite number. So it's kind of neat because you have to think about what prime numbers I would multiply to get a composite number. So for example, if I want to figure out what prime numbers to multiply to get to 4, well, think of your prime numbers. Your list is 2, 3, 5, 7, 11, 13. What prime numbers do I multiply to get 4? It would be 2 times 2. So the prime factorization of 4 is 2 times 2. Okay, so that's basically what it is. You're rewriting every composite number of a multiplication problem using prime numbers. Okay, so 6. If I would multiply prime numbers to get 6, I would do 2 times 3. So the prime factorization of 6 is 2 times 3. So 8. So I have to get 8. So a lot of kids always say, well, 2 times 4 is 8. But 4 is not prime. So you actually have to break down 4. We know that 4 is 2 times 2. So 2 times 2 times 2 actually gets us 8. So the prime factorization of 8 is 2 times 2 times 2. because 2 times 2 is 4. 4 times 2 is 8. Okay, so I am going to show you a strategy to be able to come up with these, but these you kind of should be able to see without doing the strategy, so that's why I wanted to go over them. And then 10, you need to multiply prime numbers to get 10, and that would be 2 times 5. Okay, so all of that's what prime factorization is. We're basically just breaking down every composite number into multiplying prime numbers. Okay, it's like a secret message or like a puzzle. So in your packet that I either gave you or hopefully someone picked up at the office, this is page 2 in your packet. You did the front and back of page 1 2 days ago, and now this should be page 2. So I want you to find this in your packet, second page. If you did not pick up the packet or have someone pick it up for you, you're going to have to do these notes in your notebook. So I apologize. I tried to help you out and get you the notes, but they're still in the office if you want to pick them up, hopefully soon. So do that if you didn't pick it up. Okay, so just some notes about prime factorization. So a prime number is a number greater than 1. We did this yesterday. Greater than 1 and has exactly 2 factors, 1 and itself. So prime numbers are actually called the building blocks of all numbers. So just like what we did up here, we broke down every composite number with prime numbers. So we use prime numbers to build composite numbers, okay? So make sure you copied those notes on page 2 of your packet. I'll pause, give you a second. Okay. So if you're not ready at this point, pause the video. That's the luxury of not being live. So we are actually going to find the prime factorization of 600. So that one you obviously just like can't do in your head like 4. So I'm going to show you 2 different strategies that you can use for this. So I will say that the upside down cake is my favorite. I think it's very like straight to the point. It's the easiest to keep organized. So I'm going to suggest you use the upside down cake moving forward. But I will show you the trees. Some kids like just love the trees and want to use that as the strategy. And I'm not going to make you use a certain one. I like to present strategies and say, use it if it helps. So you do what you want to do. Okay. So we're going to start with the upside down cake and then I'll show you the trees. So when it comes to the upside down cake, it's already written on your paper for you. So it's going to look a little different when you're actually making the cake yourself. So I'll show you an example of that in a second. But so all of these little upside down kind of turned L's, those are actually like the layers of the cake and you'll kind of see it at the end. But those actually mean to divide. So we're going to divide a bunch of times and you can use your calculator. So have your calculator out and ready to go when you're doing these lessons. Okay, so we're going to find the prime factorization of 600. So 600 goes in our first layer of cake. Okay, so then I always want you to have that list of prime numbers ready because what we want to do is we want to keep dividing out prime numbers from 600 that it's divisible by, and that's going to help us get our prime factorization. So I always like to start with 2. Start with your smallest prime number and see if the number is divisible by it. So is 600 divisible by 2? It is. It's an even number, so it's divisible by 2. So you always want to put the number you're dividing by on the outside of that layer. Notice it's kind of like a division sign, but it's a little upside down. So then that tells me I want to do 600 divided by 2 to get 300. So 300 would go in our next layer. And we're just going to keep dividing out prime numbers until we get to 1. So we can't divide anymore. So Is 300 divisible by 2? It is. It's even. So we're going to divide by another 2. 300 divided by 2 is 150. Okay, so 150. Is that divisible by 2? It is. So divide out another prime 2. 150 divided by 2 is 75. Make sure you're writing this down as I'm writing it down. Okay, so 75. Is 75 divisible by 2? Ooh, it's not divisible by 2. Is 70, so then you jump to your next prime number, which would be 3. Is 75 divisible by 3? Type it into your calculator if you're not sure, and it actually is. So now we're going to start dividing by 3. 75 divided by 3 would be 25. Okay, so stick with 3. So is 25 divisible by 3? It's not. So then you jump to your next prime number, which is 5. And 25 is divisible by 5. 25 divided by 5 is 5. And then we know 5 is divisible by 5. And that gives you 1, which is your candle on your cake. It's kind of like an upside down cake if you turn your paper upside down. Okay? And then your prime factorization is actually right here. So your prime factorization would be 600 equals 2 times 2 times 2 times 3 times 5 times 5. And if you notice, all of these are prime numbers. They should always be prime numbers. So I always want you to check to make sure we got the right prime factorization. So I want you to take a minute right now, and I actually want you to multiply 2 times 2 times 2 times 3 times 5 times 5, and make sure you get 600. So make sure I am correct. So go and take a minute to do that right now. Okay, so hopefully you did it and you got 600. I did it and I got 600. So we are good to go. Okay, so that is the upside down cake method. I'll show you another example in a minute for another number. And I promise you that is definitely the easiest method to use moving forward. So in case you want to use the trees, I'm going to show you that method right now. It's very, very similar. So you want to start with the number you're finding the prime factorization for at the top, which we're finding it for 600. So you want to break down 600 into a factor pair. So I always like to start with my smallest prime number, so which is 2. So I would do 2 times what gets me 600. 2 times 300 gets me 600. So I literally just took 600 and broke it down into a factor pair. So anytime you have a prime number in your factor tree, you're going to circle it because that can't be broken down any further. So there's one of our prime numbers for our prime factorization. Then we're going to break down 300. So what 2 numbers multiply to get 300 using our prime numbers? Well, I know it's divisible by 2. 2 times 150 gives me 300, and then 2 is prime. So we're going to circle it. So now we're going to break down 150. 2 times 75 gets me 150. 2 is prime. So then we are going to do 5 times, oh, nope, just kidding, not 5 yet. 3 times 25 gets me 75. 3 is prime. And 25 breaks down to 5 times 5, and those are both prime. And I'm going to show you an example of me actually drawing the tree in a second, and I promise you it seems a lot easier when you actually see me drawing it. So then, same thing. You should have the exact same prime numbers. 2, 2, 2, 3, 5, 5. So notice you have the exact same prime numbers in your tree as you do in your cake. Okay, so make sure you have those notes written on the paper, and then I'm going to show you 2 more examples, and then you try one on your own. Okay, so 2 examples for you. So I'm going to find the prime factorization of 32. So I'm going to use the cake for this. So I want you writing this down as I go. So 32 is going to go in my first layer of cake. So I'm going to make a little layer out of it. So I always want to divide by the smallest prime number I can possibly divide by. So my smallest prime number is 2. So 32 is actually divisible by 2. So we're going to put a 2 on the outside of that layer of cake. And then we're going to divide 32 by 2, which is 16. So 16 goes in our next layer. So then we want to take 16 and see if we can, what prime number we can divide by. It's even, so I know it can divide by a 2. 16 divided by 2 is 8, so that goes in our next layer. So 8 is divisible by 2, so I'm going to keep dividing out the 2's. 8 divided by 2 is 4. 4 is still divisible by 2. Keep taking out 2's. 4 divided by 2 is 2. Well, 2 is divisible by 2. And then I get my birthday candle 1, because 2 divided by 2 is 1. So then my prime factorization is all the numbers on the side. So 32 equals 2 times 2 times 2 times 2 times 2. And if you multiply that all together, you should get 32 if I did it correct. Which I did, I promise. Okay, so that is the cake method. And like I said, I think that is the easiest way to do this. The more you do it, the better you get at it. So 132, I will do the tree method. So we're going to take 132 and we're going to write a factor pair for it. I always like to use prime numbers right off the bat. So I know 132 is divisible by 2. So 2 times what gets me 132? You would just divide 132 by 2 to get 66. 2 is prime, so I'm going to circle it because I'm going to pull that out from my prime factorization. So then I need to break down 66. 66 is even. So 2 times what gets me 66? 66 divided by 2 is 33. 2 is prime, so I'm going to circle it. Then 33 is not divisible by 2, so then I jump up to 3. It actually is divisible by 3. 33 divided by 3 would be 11. So, oh, look, so 3 is prime, and actually 11 is prime as well. So I'm done. I can't break down any more numbers because they're all prime. So my prime factorization would be 132 equals 2 times 2 times 3 times 11. Okay, so that is the tree method, and then the cake was the last one. Okay, so I would like you to pause and attempt to use whatever method you want for 144 and find the prime factorization for me, okay? This one's going to be a little long, but you can do it. So cake or trees, whatever one you want to do. So pause and try it for me. Okay, so you better pause. I'm giving you an evil glare right now if you didn't. But, so 144, I'm going to do the cake because I think that one is the easiest. So 144 goes in my layer, and I know that 144 is divisible by 2. So I'm going to divide by 2, and 144 divided by 2 is 72. So 72 is divisible by 2. So 2 goes outside. 72 divided by 2 is 36. 36 is still divisible by 2. So we're going to divide out another 2. And 36 divided by 2 is 18. Well, lucky for us, 18 is still divisible by 2. 18 divided by 2 is 9. So at this point, 9 is not divisible by 2. So bump up to 3, which 9 is divisible by 3. 9 divided by 3 is 3. And then 3 is divisible by itself, which is 3. And then you get 1, and there's your candle. So the prime factorization is numbers on the side. So 144 equals 2 times 2 times 2 times 2 times 3 times 3. Okay? And there you have it. There is prime factorization. Okay? So I want you to flip the page after you have all of that work written down on your note page. And this is going to be your practice for today. So I'm going to go and show you how to do 12 using the factor tree and the upside down cake very quickly. And then that way you have something on this worksheet to look at when you're doing examples. So 12 using the factor trees. Always start with the number at the top, and then you're going to break it down into a factor pair with a prime number. So I know that 2 times 6 gets me 12. 2 is prime, so I circle it. And then 6 breaks down to 2 times 3, which both of those are prime, so I circle them. And so the prime factorization of 12 is 2 times 2 times 3. Okay? And all of the steps are written out for you here. If you forget what to do, just go look at it and try to figure it out. So the upside down cake would be 12 goes in your first layer, and you want to divide out prime numbers. So 12 is divisible by 2, so it goes on the outside. 12 divided by 2 is 6. 6 is divisible by 2, so it goes on the outside. 6 divided by 2 is 3. 3 is not divisible by 2, but it is divisible by itself of 3. 3 divided by 3 is 1, so that gives you the candle. And prime factorization is 2 times 2 times 3. Okay, so copy those down on the worksheet, and then you are doing, I want you to try both methods for 48 just to see which one you like the best after trying both. And then on the back, there are 8 problems to do. So yes, there is a back to this worksheet to everyone who told me they didn't know there was a back to the first one. So make sure you do the front and the back of this. And please let me know if you have any questions. If you are a strictly online kid and you want to see me do more problems, jump on my Google Meet at 11:30. If you're a hybrid kid and you have questions, just email me and I will try to chat with you on Securely or do the best that I can to help you, okay? Have a fabulous day, and don't forget to do your formative.